Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome. Thank you for tuning in. So we are here to change our world with chemistry. So we are going to study organic chemistry today, and specifically we are still talking about alkanes. So today we are actually going to be talking about the importance of alkanes in our daily lives. So by the end of this lesson, students should be able to discuss or be able to give the reasons why they study organic chemistry or why they study alkanes. So one of the applications of alkanes is what we are discussing about last time. Let's first really talk about it very well. It's actually about reforming, subjecting linear alkanes in presence of catalysts to transform them to branched cyclic or aromatic compounds. So this is a very good application, especially when we are talking about what we call octane rating, or we are talking about applications of alkanes as fuels. As what? Fuels. Normally, as we said, when we have straight chain alkanes, they burn at a higher temperature, or they boil at a higher temperature compared to the branched alkanes. So for example, if octane is used as a fuel, it is better we use the branched alkanes because for them, they burn at a, or we can say burn, or we say evaporate or burn, they burn at a lower temperature. So you observe that the engine will not use a lot of energy, hence it will not knock, or hence it will not make noise. Hence, we talk about this as what we call the anti-knocking property. So here in our note it says that it is good to note that the branching improves on the octane rating. Actually, we are saying branching improves on the ability of our petrol to burn at a lower temperature and again producing the same amount of energy. So hence improving on the anti-knocking properties. So it helps when our engine is not working at its maximum. You'll observe that it will work for a long period of time and it will not even make noise. So hence we are saying that the branched alkanes improve on the octane rating, where octane is used as a basis for all our ratings of additives of petrol. So we are not going to go into those details, but we should know. So here it says this explains why isomers, branched isomers of octane like 2,4-trimethyl pentane, actually this one is given an octane rating of 100%, have a higher octane number, which is 100, hence a better fuel additive. A better fuel what? Additive, yeah. So we can also talk about other fuel additives like tetraethyl lead and methyl what? Benzene, or methyl benzene. Methyl what? Benzene. But we say this lead is not good, especially because it pollutes our environment. It also pollutes our bodies because it causes things like brain damage, nervous illness, kidney damage, and also high blood pressure, all those things. So it's not good advice for us to use leaded petrol. Leaded what? Petrol. So let's continue. We are going to continue and talk about our more applications. So this time, these applications, we are going to discuss about it in terms of crude oil and petroleum. Crude oil is obtained as a dark oily liquid from the earth crust. From the earth what? Crust. And crude oil exists together with natural gases. So we are saying that this crude oil is a source of alkanes, and these alkanes which are very important in our daily lives. Like for example, crude oil is obtained from the ground and separated into fractions. So this crude oil can be obtained under lakes, can also be obtained in the wells. So it also obtained from different countries, from different what? Countries. So when this crude oil is obtained, it can be separated into fractions, which are very important because most of them contain a lot of alkanes, yeah. So the components of crude oil are separated on the principle of that they have different boiling points. So during fractional distillation, crude oil is directed into the furnace and heated up to 400 degrees what? Centigrade. So as they are heating, you know, because these components of crude oil have different boiling points, they will evaporate. So evaporate using the principle of their difference in the boiling point. So here we have a simple illustration showing you the different what? Way of separations. Like for example, here is our furnace where we heat as the crude oil is coming from here. So we have got it from the lake and we are putting it in our fractional distillating tower. And here we heat. As we heat, they will evaporate. So here we have different plates which control the separation. So you observe that for this one to move to here, it's supposed to be above 300. For it to move to here, it's supposed to be 200. So it helps us in our separations. So our natural gas is obtained, that is from methane up to butane. So our next substance which is obtained from crude oil is actually gasoline. That is from C5 to C8. That is, we can say, from pentane up to octane. So this petrol is the one we normally use in our vehicles. Then we also have naphtha. We have what? Naphtha. Naphtha is from C5, from C8 to C10. That is from octane up to 10. Then we have kerosene. This kerosene is one we normally use for cooking and normally use for as fuel also for aeroplanes. That is from decane up to tetradecane. Then we have diesel. So as you see, normally as the sizes increase, even the boiling points will also what? Increase. So diesel oil from C15 to C18, and then we have our residues here containing lubricating wax and all other details. So you see, our crude oil contains many important what? Alkanes. So though it's a mixture of different what? Products. Then, so we are going to talk about the different uses of our different components. As we have said, we are talking about the applications of crude what? Oil. Or we are talking about the applications of alkanes. Or we are talking about the uses of what? Alkanes. So alkanes in form of natural gases are basically used for cooking and lighting. Used for cooking and what? Lighting. Then petrol. This percentage is just showing us the amount of the petrol which we can get from this quality of crude oil this time. Maybe probably from this crude oil was obtained from Brazil. So then here, petrol is very important. It acts as a fuel in vehicles, engines, and generators. So generators help us also when electricity has gone. Then they can act as solvents for grease and paints. So as you know, when they are making paint, this paint is normally mixed with an organic what? Solvent. So that organic solvent can be petrol. Can be what? Petrol. So petrol is basically known in use in vehicle engines, that is cars. Then petroleum ether basically used in the manufacture of organic chemicals, sometimes a component of petrol also. So manufacture of different organic chemicals we use in the lab, we use in our daily lives, like for example, the different alkanes. So as we have talked about cracking, we can even crack them and we form small organic what? Compounds. Then we also have kerosene. Kerosene acts as a fuel for cooking and lighting. It can also act as a fuel in aeroplanes. It can be used to make extra what? Gasoline by cracking. So as you've seen here, if you look at our diagram, our kerosene is is C10. See what? 10. So if it was an alkane, like for example, C10, H what? H, C10H, that is 10 times 220, 22. So it means we can crack it. So we can crack it to produce, like for example, C5, H12 plus what? C5H what? 10. So these ones can be components of what? Of petrol. As you see, if you look at, let's look at our slide again. If you look at our slide again, you'll see that gasoline here follows from C5 to C8. So when you crack, for example, kerosene, you can get what? You can get gasoline. You can get gasoline. As we said, normally in these components of crude oil, we have a mixture of organic compounds, but the highest amount is actually alkane, or it is good for the highest amount to be alkane. Then diesel acts as a fuel in heavy vehicles, lorries like tractors and trains, and also used in generators. Then we can also say can be used to make extra what? Gasoline by cracking. So we are still talking about the applications of our organic compounds. So then oil can be used as a residue, as oil and wax, used to make heavy oils and lubricants, heavy oils and lubricants. So in our residue, we have oil and wax. So it can be used to make heavy oils, lubricants, normally the ones they use in engines, used to make candles, making petroleum jelly, meaning from this residue we can also get our jelly, or we call it, can call it Vaseline we normally use. Then asphalt and bitumen used as to make protective coatings on road surfaces. As normally when you see when they are building roads, they normally apply this black substance. Some of those black substances come from our crude oil. So those are some of the applications. So we are still talking about the applications of our alkanes. So we are now going to first talk about some of these also again. So methane, as methane, not in a group of natural gases, is used as fuel at homes, ovens, water heaters. So fuel in kilns, automobiles, as it combusts with oxygen to produce heat. So this heat is very important in cooking, in ovens, also for cooking, especially water heaters, that is for bathing, kilns, that is for in the industries, and especially in the automobiles, that is different cars, or we can talk about the small cars. Then highly refined liquid methane is used as rocket fuel, so we can use methane as rocket what? Fuel. That means to move rockets. Then methane is used as a fuel for electricity generation. So we can also use methane when we want to produce what? Electricity. That is, for example, you can call this in generators. Then it is used as a vehicle fuel in the form of liquefied natural gas. So it can also be used as a fuel, as we've seen. So methane can be used as a raw material in production of urea as a fertilizer. In general, methane is more environmental friendly than gasoline and diesel. So you'll observe that methane will produce less pollution. So despite the fact that we are saying these organic compounds are very important, they also cause environmental damage, meaning they cause a lot of pollution. So the bigger the substance, the more energy it produces, and the more pollution it causes. So that's why sometimes, because of our environment, it's better we use methane. It's better we use what? Methane. So let's continue. We talk about butane. Again, before we talk about butane, we would have talked about propane, but let's first talk about butane. So butane is a key ingredient in synthetic rubber. We shall talk about rubber in Senior 6. It is used as a fuel in cigarette lighters also. Those people who enjoy these things, tobacco, then blended with the propane and the other hydrocarbon, it may be referred to as liquefied petroleum what? Gas. So mean it can be used as a fuel, also in cars. Butane gas cylinders are used in cooking. So I think you normally see these cylinders. There are very many, especially in our country, and most of those cylinders contain a gas, but normally in liquefied form, and this gas is very important in cooking, especially in our daily lives. Also is used in aerosol spray cans. These aerosol spray cans are basically used when we use them when we are making, for example, perfumes, making of those compounds which normally move out of our, we normally press. Like, for example, we can have pesticides, we can have, but basically most of them are perfumes which are very common because you press and the substance comes out. So the ability of that substance to come out may be also caused by the substance which is inside, meaning butane this time can be used in aerosol cans as an organic what? Solvent, or we can call it a propellant. Propellant meaning it can help the substance which you've mixed with that substance to move out of the can. So it propels it what? Outside. So propane, again, is used as a, we are now talking about propane as a propellant in aerosol cans, such as shaving creams and air fresheners. I think you know these things like shaving creams, the ones they normally use these in the salons. And also air conditioners, the ones they normally use in our toilets and bathrooms to keep away the bad smell. So used as a fuel for home heat and backup electrical generation in sparsely populated what? Areas. So it can be used in generators to produce what? To produce electricity. Propane is commonly used in movies for explosions. This is one of them also. In movies, people enjoy movies very much. You can use propane in our movies. Then now let's talk about ethane. Ethane is used in preparation of ethene and certain heavier hydrocarbons. Ethane can be used as a refrigerant, meaning that we can put it in a fridge. For example, if you look at the structure of a fridge or what we call our air fresheners, inside the air freshener or a fridge, you'll find there are some what? Small pipes. There are some small what? Pipes. Small pipes. There are some smaller pipes. They are normally very small. Sometimes you may ignore their importance. So, and down there normally there is a pump. You can say a pump. So we have a pump, so, and all these are connected to that what? Pump. So what happens is that if you put your substance here, you want to for it to become cold, so this pump will pump the liquid up when it is very cold, so it will come and collect the dryness, or we can say it can collect the heat. So when it collects the heat, it will change to gas. So when it changes to gas, it will run very quickly and go back here. So the pump, we shall have a condenser also. It will cool, then again it will pump it like that. So it will be rotating. That's why when you switch off these refrigerators or our air fresheners, they always make noise because there is a liquid which is moving. So we are saying that some of the liquid we can use here is what? Ethane. Refrigerator liquid. refrigerator what? Liquid, which we normally call a refrigerant. Then in pentane, the use of pentane is used in production of polystyrene foams. We shall talk about polystyrene as an application of polymers. So used in laboratories as solvents also, organic solvent, can be used in making of pesticides, these ones which kill different pests, and used as a solvent in liquid chromatography. Then let's talk about hexane. There are many. Hexane is used in the formulation of glues for shoes, leather products, and roofing. So we can say glue. Glue is normally, can talk about the one which helps our shoes to be able to attach themselves. Like, for example, if your shoe has got a problem, they normally can put super glue for it to attach. But this type of glue they are talking about can be the simple one, the simple glues, which we can call paper glues. Then it's used to extract cooking oils, so we can use it in solvent extraction. We shall talk about solvent extraction. Solvent extraction is normally called liquid what? Extraction. Liquid extraction, where we shake, for example, if I want to separate my, for example, soya, if this is my soya, so we can remove the covers from soya, then we crush our soya into powder, then we mix the soya with the, you can look at the blackboard, we mix the soya with the water maybe, then we boil, then after boiling, we shake it with the hexane, normally cyclohexane. Hexane. So as you're shaking, this cyclohexane will mix with this substance and it will collect the what? The oil particles. Because normally, as we said, you can look at the blackboard, normally as we collect, as we say that these organic substances have the ability to absorb other organic substances because they are organic solvents also. So as they collect this substance here, they will be able, as you mix, they will be able to collect the oil. So this oil will be entering inside the what? It will be inside the cyclohexane. So they shake. As they shake, the cyclohexane will collect the oil. As it collects the oil, leave them to settle. So after settling, you shall have these ones here, the ones you don't want. Then you shall have your cyclohexane. Cyclo what? Hexane plus what? Oil. So you can evaporate this because cyclohexane evaporates at a lower temperature. So we are going to say hexane is also used in extraction. Again, this is solvent extraction. Also used in cleaning, that is cleansing, disgreasing. So for example, when we can compare this with the dry cleaning. If you want to clean your cloth and it's dirty, you can apply some of these organic compounds because when you use them, after some time they evaporate. So as you clean, after cleaning, it will evaporate. So within seconds, your cloth will be very dry. So let's talk about heptane. Heptane is used as a solvent, so many organic compounds are used as organic solvents. Then used in research, making of medicine. Also, it can be found in gasoline and also an organic solvent, basically. So these are some of the applications of our alkanes. But as you see, the biggest application is actually fuel. Is actually what? Fuel. So I'm going to leave you with some assignments saying using equations, show how the following compounds can be prepared. Can be what? Prepared, and then explain why butane may be considered as a better fuel than methane. We have tried to discuss about that. So, like for example, if you look at question number 1 saying using equation show how the following compounds can be prepared. I can do for you number 1 only, then you try out the remaining. So I'm going to try for you our exercise 1 here. Exercise number 1. So number 1 only, very, very quickly. So we are going to say we want to convert CH3, CH2 chlorine to CH3, CH2, CH2, CH2 bromine. So you see we have multiplied, we have increased the carbon chain. So immediately we make this thing very big by, so in presence of dry ether, dry what? Ether. Then we have CH3, CH2, CH2, CH3, plus sodium. That's what? Sodium chloride. Then, you see now I'm going to add the other bromine, CH3, CH2, CH2, CH what? 3, plus what? Bromine, in the presence of UV what? Light. So we can get our compound. Though it's not the major product, but we can get it as this. CH2, CH2, B what? R plus what? HB, R. So you've seen that we have increased our carbon chain first, then after we add bromine, then we get our product. So we can apply the same, we shall apply the same here on part B, somehow similar as you do this assignment here. So here you observe that now this time we have propanoic acid to nitro what? Ethane. So what you can do, you reduce the carbon chain. You remember the chemical reaction we talked about, which reduces the carbon chain. We get this propanoic acid, we react it with sodium hydroxide, then the chain will reduce, then after we add nitric acid. Then C, we can add hydrogen. After adding hydrogen, we add our bromine in presence of UV what? Light. Thank you very much for following me today. Hope you can be able to give the different uses of alkanes, and you've got the reasons why we talk about or why we normally study our alkanes. Organic chemistry is basically very interesting, very, very interesting. And see you next time. God bless you very, very much.